Привет! Как дела? Хорошо, отлично, хорошо. All right. That was my entire Russian. Все, меня русский язык знаю. I don't know. Moving swiftly on, I'm from Zurich, Switzerland. I'm the head of engineering at Archeologic, which is a small company that does WebGL visualizations in the browser, and you can interact with them for real estate. So that means you give us your floor plan, and we give you an interactive 3D model. We also do very serious things like this. This is me using the HTC Vive to have laser sword or lightsabers in the Millennium Falcon. And it's in the browser, so it's not a native app, so yay, that's fun. I also happen to be a Google developer expert for web technologies and a Mozillian. I have contributed to Mozilla a few times. And I also work with the W3C on things like the WebVR specification as well as other things. Great. So today, I'd like to talk to you about what VR actually is good for, because a lot of people think it's just a toy and it's not really useful. And then we're going to have a look at how WebVR kind of comes into the mix, because then if you understand that, that VR is useful, a lot of people go, but the web is too slow, so you can't really do VR with it, and you should totally use Unity and stuff like that, which you can. I'm not saying it's a bad idea, it's just you have to understand the implications. And then finally, we're going to move forward. So once we have an understanding of what WebVR does and how we can actually get VR experiences to the web, we're going to look into how we can connect multiple people in the same virtual space using web technologies. And last but not least, I'll wrap it up. Okay, let's start with VR. So there's a bunch of things that have popped up in the last couple of years, particularly because we basically have been in this new wave of VR, right? VR is not a new thing. The first VR device has been conceived in 1960 or 1964 or something like that, and it was called the Damocles sword, and it was an apparatus that was gigantic, and you would be like strapped to a thing, and it would look horrible, and you could not actually do this. And then we had the 90s, where things like the Virtual Boy came to the market, and they flopped because the hardware wasn't ready and the software wasn't ready. And we are basically just starting to grasp what we can do with computers. And today we have a slightly different situation. When the Oculus was kickstarted, shortly afterwards, Facebook bought it for, I think, $2.something billion, and that kind of spiked new things. And then Google went, it's a very nice thing you have there for $2 billion. How about this cardboard for 5? Just saying. They had very different devices, but still it was quite interesting to see what happened afterwards. And then you get applications like this. So this is Google Earth. And it's quite funny because you basically just point at things and then you fly towards them. So if you do that while being in Manhattan, you can go like, woo, woo, and you just zoom from building to building like Spider-Man. That's quite fun. Also, you have things like this, which is a concert. So basically, you are at home in the comfort of your sofa, but however, you are at the same time feeling or seeing as if you would be at a concert. So you have a seat at a concert, and in this case, it's not an actual concert in the classical sense. It feels like you get a private show because you're the only person in the room. This is a more limited experience, so here you already start to see differences. So here I can use this pointer device to move through space, while here I am basically strapped to a seat, so I have to be stationary, so I can't move around. I can't go check out what this guy is doing, for instance. I have to sit here and watch him from the distance. And then there's cool things like Tilt Brush that allows you to do things that you literally can't do in real life. Because, okay, fair enough, you can't do this in real life as well, but I would love to be able to do that, because well, actually, it might feel a bit weird. Just imagine there's a bird in the way. Ow. Anyway, so what you can do here is you can create things in virtual reality, and that means that you can create things that you can't easily create in real life, such as you can basically paint in three-dimensional space and then go around it and then add something here, and you can't just put like colors on or material on the ground and have to build things up, because there's no gravity. So you can paint and build whatever you want, right? You're not constrained by real physical world constraints. And also you're not constrained by physical world constraints in terms of materials. So here you see Bagger. So she's using light here, and I think she is also using, yes, there's light used here. But there's also materials that react to music, so you can play music and then have the colors change, for instance, or you can have sparkles or running water. So you could theoretically draw a waterfall and a river if you wish to. And I think that's very hard to do in real world. But there's other cases as well. So these are like a few showcases, but you might be like, yeah, but my company is doing something completely different, so I'm never going to get to play with VR. There might be. There's a few things that are not very obvious. One thing is, for instance, education. It just gives you a very different feeling to have the impression of being somewhere that you can't physically be than just reading about it or seeing something on a film. So if you see basically a picture or a movie of the Great Barrier Reef, for instance, you're still having a sort of distance. So like, okay, yes, there's beautiful fishes and all that kind of stuff, but I'm here in this room and it's boring and it's school and that. But if you're actually kind of swimming with the fishes, that's a very different thing. And researchers have found that primary school children, so children from the age of 6 to probably the age of 9-ish, are actually having, it's a good thing and it's a bad thing, actually, I believe. So they're having trouble figuring out what was real and what wasn't when they were in virtual reality. So they really identify with the environment they're in, because the sensory input, the things you see, the things you like, how you control them with your body, makes it very, very hard for them to distinguish between the differences. Which can be good if you use it correctly, because they really learn by actually experiencing something. On the other hand, it can be also a problematic thing if it's an experience that is not very good. I don't know, like a zombie game or something. That's probably not something that you should put your toddler in. There's also applications for healthcare, and that has two sides to it. One thing is, you can use this for therapy. So curing someone from, for instance, the fear of flying with a plane is a bit tricky, right? They have to go to the next airport, you have to have a plane that is designated for this, and you have to put people in, and then some people get super scared and go out, and then that was the only day they could do it this month, so they have to wait another month to get another chance if they have to abort. So it's a tedious, expensive process. But with virtual reality, because your brain is, fear comes from the brain, really, and from the hormones and substances in your brain that make you feel something that is irrational. Might be rational. I mean, fear of heights, falling down 400 meters is probably a rational fear if you're on a mountain. But anyway, so basically, VR convinces your brain to send the same signals, to use the same substances if you're in the situation. But you do not have to be in the situation. So basically, you go in, and you're like, okay, this is too much for me. You put it off again, and you're like, oh, okay, I'm calming down now. And then you put it on again, and you're like, okay, I got this. Okay, no, I don't have this. So, yeah, it's funny, but it's not funny for the people who are involved with this. And there's a bunch of people that have interesting anxieties. There's the anxiety that peanut butter sticks to your mouth and anyway. And there's a very long word for the fear of long words, which I find very evil from the doctors. But there's also the training aspect. So you know that surgery is really complicated and training on real humans is limited. So I'd rather have someone to go snip, oh shit, it's dead, in virtual reality than in real life, right? Now obviously that doesn't happen too much, and they practice on dead bodies to begin with, but nonetheless this cuts the cost and actually gives you more training opportunities, and more training opportunities, in my opinion, is always a good thing. So we have training and therapy in healthcare. And then obviously we have the thing like where it's spatial data. So if you're an architect, you most of the time actually draw things in 2 dimensions. I work with architects, as our founders are architects. And they're like, yeah, as an architect, you have this problem that you're basically trying to figure out how to communicate between all the different people. Like the person who's building the building, the person who's living in the buildings might be a different person, the person who's actually putting like concrete on top of other concrete and all this kind of stuff. And then you're like, you have this drawing that has, okay, so this wall has to be a little thicker so that we can get that pipe in. But if we get that pipe in, we have the problem that then we have to figure out how to insulate this against like outside influences. And then we have the window, but we can't put the window here. So they have to actually juggle with a lot of very abstract problems, such as we do when we do software architecture, unless we do, which some people do. There's situations, it's basically like in software. You know that basically the earlier you catch a bug, the cheaper it is to fix it, right? If you have test-driven development and your test fails and you're like, oh shit, I have a regression here, you fix it, basically no time has been spent, and that means that no cost has been spent as well. But if it's deployed in production and you fix it, someone will go like, actually, I have this script that relies on that bug that no longer works, and I'm going to sue you. So more expensive. And architecture is the same thing. If you have a drawing, erasing a line and drawing a new line is really cheap, but actually tearing down a building is not. So they are really happy that they have a possibility to get a more immediate feedback as well, because that's important for them. Rather than having a line, you actually stand there and see like, all right, that window is too small, it's pretty dark in this room, I should fix that. Very easy to do as long as you do it early on, right? And then there's design arts. So you can do art projects, installations, things like tilt brush. You can create things in virtual reality. You can create experiences. You can create movies using virtual reality. And you can design things like if you're a product designer, if you're designing a car, that's also something that might be interesting to see how it actually behaves and looks from different angles. And then things that are not as obvious, like journalism and entertainment. So entertainment is kind of obvious. I'm not going to name what entertainment is included in that, but also like games obviously can use VR. But journalism is actually also a very big topic. New York Times shipped, I think, 500,000 cardboards, Google Cardboard VR devices to their subscribers because they use it as a storytelling device. So for instance, you can visit a refugee camp in Syria, or you can climb up a mountain, or all that kind of stuff. It's really, really interesting, and it gives you a very different perspective when you're actually standing in the middle of what's happening rather than just reading the words about it, or just seeing pictures or videos. And then marketing, so you can basically market your product using VR. Real estate marketers like that. Yeah, and journalism is actually also interesting because it's a form of responsiveness. So you can still have your article written in text, you still can have your videos and pictures, but if this person happens to have a VR device, they can also extend their experience using the VR device. That's not as easy with construction and architecture. So what we do, for instance, is when you are on a really old device, you get an image, a static rendering of the VR, of the three-dimensional space. If you are on a computer that does not have a VR device or a phone, a phone that does not support VR for various reasons, then you get a virtual reality, no virtual reality, but you get an interactive 3D thing. And if you actually have a VR device, you can press that little VR button and actually go in as well. That also works on phones because we basically go, if you happen to have a cardboard, there's a button you can press. Right. So this is more or less the landscape as it is of today. There's more than that, but most of them are basically glorified cardboards. So the most popular ones are probably the Oculus Rift from Facebook, the HTC Vive, which is what Steam is selling, Google Cardboard because it's ridiculously cheap. Like I think this is $599. This is $899. This is $5. Slight difference in price, right? Then we have the Gear VR. That's a Samsung device. It's basically a cardboard, but specifically for Samsung devices, and it has a little touchpad, and it's actually can be quite nice. That's $99. Then we have the Daydream. That's $79, I think, from Google. That only works with certain phones, not with all phones, with basically no phones really right now. But we are getting there. And this is the OSVR. That's like an open source thingy that tries to not have patents on all. Like you can't really clone this very easily, but this is fine. You can build your own thing, and there's a bunch of companies that build these things. Razer, for instance, and they have very different capabilities. Это responsive design. Хорошо? Хорошо. Давайте. I only noticed it now, and the internet is super slow. I'm like, yeah, I'm not gonna fix it and then have like everything reload. So let's just stick with it. So as you can see, there's like price differences, small price differences. And there's also things like with a phone, you know where the person is looking at, but you don't know where in the room the person is. So you can't do things like, and now I'm gonna take a step to the left. There's accelerometers, but they are too inaccurate to actually make that work nicely, so don't. So basically, you can only turn around with a phone and see what's around you, like the concert experience, for instance. Or the Google Earth thing would actually work because you have a different device, but you don't really have that device on a phone, right? So yeah, it's a bit tricky. And then you have, so position tracking. Position tracking is different from room scale tracking. Position tracking for Oculus in the beginning meant you can do this, and this, and this, and you can sit down and stand up. But if you want to do this, that didn't work, because they had like a camera, so you would have to stay in front of the camera, and that was not particularly great. Whereas the HTC Vive instead had two sensors that you would have to put in the corners of the room, and you could walk around in the room, which is nice. Oculus and Vive come with two controllers, so you have basically hands, because theoretically, if you think about it, you know where the person is and which direction the person is looking at, but you have no idea what the hands do. And most people, what they do when they go for VR the first time, they look down at their hands and they're like, where are my hands? Where's everything? I'm a floating pair of eyeballs. That's weird. And with the controllers, you at least see your hand. Well, you don't see your hands. You see the controllers, and you can go, okay, I have a button. Okay, I can do things. So that's nicer. The Gear VR, as I said, has the only way of controlling things is a touchpad that allows you to like scroll and tap and double click and all that kind of stuff. The Daydream device comes with a handset kind of magical wand that you can press on, and it has a few buttons, I think. So that's paired with the device. So that's all. You can actually assume, okay, this is a Daydream. So the user has this device. Whereas with the cardboard, you at the best case, the first cardboard didn't really have a button. They had a magnetic button that only works with very few phones. But the newer cardboards have a button that basically touches the screen. So you have like, you press down the button and then a tiny piece of foil that pretends to be your finger touches the screen for you. So you have that interaction, but it's a very limited interaction. However, these last three, the Daydream, the cardboard, and the Gear VR are mobile, so you can take them with you, which is nice. The HTC is very hard to set up because you have to get the sensors up, you have to calibrate, you have to have a powerful PC, and it's not very nice for mobile actions. But I think we're going to see more of that later. And that brings me to the difference between the web and VR, as classical VR. So the web is about sharing. The good thing about the web, or I think the biggest power of the web is, you go to a website, you check it out, you go, ooh, this is nice, you copy the link, and give it to someone else, and if they have internet, they can just use whatever device they have. They can use a potato if it has a browser, really, right? So it doesn't matter if you're on a Raspberry Pi, your Nintendo console, your Nintendo Switch, your PlayStation, or your Xbox, your like Windows, Linux, or OS X, desktop or laptop, your phone, your tablet, it doesn't matter. As long as it has a browser and an internet connection, you are able to access the content, unless it's a Flash page. If you're still doing Flash pages, we should have a conversation. And I think what makes VR really interesting is not the entertainment bit, not the games. You play the game, you get VR, like we have a Vive in the office. We played the games for a day or two, and then that was it. Because it is fun at the beginning, but it gets tiring, and it actually is not, it's not as engaging as you think it might be, because it is kind of more or less linear-ish, right? But creating things, Tilt Brush, I still see people taking their lunch breaks to make something in Tilt Brush. And the reason for that is that creating is something that is inherent to our nature. We want to create things. That's probably why you are a developer, right? You want to, or designer, the same thing. You want to create things. You want to create things for others to use. You don't want to just create them and then put them in the basement and go, haha, I created it, but nobody knows, right? You want to share these things. And now imagine you created the most beautiful sculpture in Google Tilt Brush. And you go like, have you checked out the thing that I created yesterday? And they're like, no, how do I do this? You buy an HTC Vive, you go home, you set it up for 3 hours, and then you go back and have a lie down because you're super annoyed about it, and then you go back and then you install all the software, and then it updates it, and then you have to, get the Steam update as well, and then you can actually install Google Tilt Brush, and then you can try it out. And the people will go, oh, that time of the day already, and bugger off. And that's not what you want. You want them to be able to experience the thing that you created with no barriers. So basically what you want is you want the web character, but you also want the immersiveness of VR. And that's where WebVR comes in. We kind of want to fuse these two things together. We want to make it easier for you to create things on the web, and you also want to make it easier for you to share these things and have other people experience it in VR, no matter what device they're on. And this is the logo. I find it interesting. we are basically in the process of creating these standards. That means we need developers to try it out and tell us if it's good or not good. And there's a bunch of tools that you can use. You don't have to actually use the standards API. There's tools on top of it, and I highly recommend you try it out. And you should try it out because it is actually the easiest way to get into it. So there's, Alex Bowles said, VR development takes 3 times as long as normal development, and normal development takes 3 times as long as you think, which is mostly true. Unless you think it takes 3 times as long, then it takes 6 times as long, and so on and so forth. And that's primarily because the tools that people use to create 3D experiences are mostly tools for games, game engines, Unreal, Unity, so on and so forth. And these tools are basically saying, we are in control where the user is and what the user can do, right? We have a keyboard, we have a mouse, maybe a joystick, who knows, maybe a gamepad, but we kind of know what we are in for, right? We have this, we know we are on the Xbox, we have this gamepad with these controllers, these buttons and these triggers and all that kind of stuff, so we know what's going on. And we can take indefinite time of loading shit because it's, you take it from the internet, you download it once, and then you're good. And you're okay with the loading bar. No one is okay with the loading bar. Anyway, luckily, Ada Rose said, well, that's the thing. It's more or less the same with WebVR, except you have tools that make it really easy. For instance, A-Frame. She mentions A-Frame, that's a Mozilla project that basically is a bunch of web components that look like you're writing HTML, but you're actually creating things in 3D. So you can say, I have a scene, and then I have a box, and then I have a camera, and the box has this size and this material, and it's green, and if I press WASD, it moves around. Done. So that's a very, very different experience, and I think it's natural to the web because we never really know what kind of device we are on. Right? The screen can change, we can turn our mobile phone around and the dimensions change. We can actually go more or less directly from, have a session, the same session, or actually active sessions on different devices, and we can swap between them. So we kind of have to adapt to that kind of stuff. We have to be responsive anyways. Things might not load, right? So we have to enhance things as well. And that's what the web is about, really. And I think it's nice to have what I would call responsive WebVR. What you can totally do is you can go, you know what, I show some web content to everyone, and then when I see that they have WebGL enabled, which most people actually have, even on phones, I show some 3D content as well. Oh, they actually have a VR device. Nice, in that case, here's a button. Press that button and you go in VR. And no downloading updates, no weird stuff. You just click that button, the browser goes in full screen on the device, and you go in the device, and then you're like, woo, nice, I can do stuff now. And then what you basically do is, for instance, you create something, you paint something, and then you go out of the VR device and you get a URL. You say save, and then it gets a URL, and you put that URL into someone else's browser. You send that via, I don't know, HipChat, Slack, whatever you're using. And then this other person clicks on that URL, and then it goes, well, your browser does not support WebGL. OK, so they change to something that supports WebGL, out of Internet Explorer 6 up to Microsoft Edge, for instance. And then they get they can see it, and they can use their mouse to go around, and they can use the arrow keys or the WASD to actually move towards it or away from it. And then they might have a VR device, and they click that button, and then they can actually walk around it as well. That's really nice. I think that's really, really cool. So let's have a look at that. First things first, there's a misconception that WebVR is about, the WebVR API is about 3D rendering. It's not. It's absolutely not. WebVR gives you access to the sensors on the device and actually tells you there is a VR device here, and this is how you can render on it, but it doesn't do the rendering. The rendering is something different, right? So it does not do the graphics output. It only gives you access to where's the user looking at, where's the user going towards, and yeah, how do you get something on the screen in front of their eyes? But the actual creation of 3D output, that's what you want WebGL for. Two different things, very important to understand. People mix it up and they go like, so with WebVR, can I render? You can't render. It doesn't do the rendering bit, okay? All right, so the spec, unfortunately, is still a bit in flux, but we have so far agreement with most vendors that are participating. Actually, all vendors that are participating agree, so we have version 1.1, which is relatively stable. We are working on 2.0, but now is a good time to try out API 1.1. The first thing you do is, you check, and you can actually progressively enhance that. You can check if get VR displays is in Navigator, and if it is, then you can call the function, and then what you see is Well, there's displays. Okay, that's nice. So what do I do with the displays? Well, on the display, you can ask, hey, can I actually present? And here, use this canvas element. And the canvas element is where WebGL renders the 3D content to. So this is where the 3D happens in the canvas. And then we use that canvas and send it over, hopefully with 90 to 100 frames per second, to the actual device. And then this is our WebGL function that creates 3D content on this one. And actually what we do is we request animation frame on the display because now we want to be bound to how fast the virtual reality device can actually update. We get the frame data, so that's where the position and orientation comes from. And then this function is actually where the WebGL kicks in and actually draws things based on the position and orientation. And then we send whatever we have rendered on our browser over to the VR device. As I said, it is coming. So WebVR is enabled on Android Chrome. It is enabled in Samsung Internet. It is coming to, or it is in Firefox Nightly right now. Edge has said they want to implement it. They are not just there yet. And there's a polyfill that allows you to basically bring it to all like iPhones and Safari and whatever can render things and has a request animation frame. Good. So now we have done that. Real quick, WebVR in multiplayer. So what kind of data do we have to send? Well, first things first, our people can actually move or change their state in 6 degrees of freedom, right? I have 1 degree, so this is my first axis, 2nd degree, my second axis, I can come closer to you or farther away from you. I can go up and down, so that's 3 dimensions, right? I have this, this, and this. Okay, great. But now I can also turn around these axes. I can turn like this, I can turn like this, and I can turn like this, which looks weird, but you can do it. So that means we have to have like 6 values transmitted. So we have the position, x, y, z, in 3 dimensions, and we have to have the rotation in 3 dimensions. And because these rotations and positions are usually done in floating point, because basically a unit of 1 is 1 meter normally, we have to have float 32, which is our floating point, and the smallest floating point number that we have in typed arrays, and JavaScript for that matter. So we have 6 times 32 bit, so we have 192 bits for 1 position that we send for 1 player. That means if we want to do that with 60 frames per second, we get to 11.5 kilobit per second, which is good, because modems can do that, right? So that's actually not too bad. Unless the Wi-Fi flakes out like here, you should be pretty good. And then you can think of, but I have some administrative data, like how do I know who is actually the person who is sending this information to me, right? Because I have to update the right player. If I have 4 people and I just get a position, like who the hell is that? So we add some overhead, we have a type, because there can be different actions. You can probably jump, or jump is basically just move. You can join, you can disconnect, you can maybe send a text message to people, like chat them up or something like that. So probably if you have like 4 messages, 2-bit is fine, and then you can use 6-bit as a player ID, so you identify the player and the type of message that you're getting in 1 byte. And then we have the 6 times 4 bytes for the XYZ rotation and position. And that could, for instance, look like this. So basically here's 4 messages, player moving, I'm not even using this one, player has connected, player has disconnected. And then there's parameters for these, and the others don't have parameters. Then we have a bit of overhead in the WebSocket specification, ignore that. But basically we end up with 216-bit or 27-byte if we send a single message. WebSockets can be in binary, so that's really convenient. We don't have to use JSON, which is pretty large and cumbersome. I wanted to show a demo, but the Wi-Fi is unfortunately very flaky today. It has been relatively stable yesterday, so I'm going to skip that, unfortunately. I'm sorry. Извините. Извините. К сожалению, это не работает сегодня. Давайте. So basically, what I want you to do is build WebVR experiences, but do not use the same things you do on the web in regular. So if you do like this, people will not be happy, okay? If your marketing department goes, that's really cool, let's do like pop-ups, and you're like, no, right? Or if you don't like the marketing person you're talking to, you can go, заткнись, пожалуйста. And the key takeaway I want you to take from this is, Steve Jobs once said famously, the computer is a remarkable tool because it's the bicycle for our minds. It makes us faster than any other animal if you compare it by energy spent to move, right? It's not making you faster than a cheetah probably, but the cheetah uses more energy than we would use for the same speed of movement on a bicycle. And I want you to understand that if the computer is the bicycle for our mind, VR is the teleporter for our mind. It can take you places. Even though the graphics quality might not be good, it is convincing, as long as it's not too jaggy. And with that, I say spasiba большое. Oh. Why did I not have this?
Вижу.
Давайте. Хорошо. Я не понял.
Okay. What do you think about the future of the technology? About, for example, when, what time do we need to change? For example, classic communications in social networks to VR communications when we can use VR for feeling our opponents around you. What do you think about the future in the technology in internet, in the web? Thank you.
Okay, good question. I think right now it is a problem of the creation tools. It's the creation side that is actually a bit of a problem, because for filmmaking, for instance, you have to change storytelling a lot. But for social gatherings, there is things like that, like Oculus Home literally allows you to sit down on a virtual couch and watch a movie together. Like Netflix and chill remotely, which is interesting. I think it will take a while until like the technology is everywhere, because right now you have to have a really beefy PC for that, or actually a desktop computer for that, so you can't easily do it from your MacBook, for instance. But I think the technology is catching up really quickly, so I don't think it's going to take too long. Probably it's a matter of years. Facebook is investing heavily in it, so I guess it's going to happen rather soon, especially the social aspect, because we have become more global, right? I have relatives in I don't know how many countries. And the cool thing about VR is that we can share experiences in a very limited way, but it's the best way we've got. I can't always hop on a plane and fly to Australia. That doesn't work, right? But what I can do is, if I do like a panoramic image that goes all the way around, I can show them how it is, or how I perceive it to stand here and talk to you. And that's a very different thing from taking a picture. It's like, yeah, there's a bunch of people. It's like, ooh, oh my God, I stand alone here, and then there's like a ton of people in front of me. So that's going to happen probably. And it's really interesting to see what people come up with. Yes, I move my hands a lot, but that's actually how I do it.
Hello, Martin. Thanks for your speech. My name is Vasily, NBC's company, Tomsk. And I have several questions to you. First one, what do you think about the ability or opportunity to use web glass or VR glasses with mobile devices, like plug in like a headset and go into the deep into the VR? And second question, it might be not question, some kind of...
Oh, let's be fair. Let's use one question. I'll be around, so you can ask me afterwards.
Yeah, second one about marketing.
Ёлки-палки.
Дадим.
Ёлки-палки.
Пускай он ответит хотя бы на один.
Right. Mobile device, I think that's actually the future, and Facebook is now investing heavily in making... Gear VR is a Samsung product, but also a Oculus product. So I think mobile will be a thing. And the plug-in device, we always have to have that in some sort, because the phone, yes, you can put it... Cardboard is not a plug-in device. You basically put your phone in and then use it directly, but you still have to carry around the device. And if your phone does not have a good screen, then it might be useful to have a separate device that because you have to carry something with you anyways. Done. Yeah, all right. One more question? Because if we don't have a question, then there's plenty of questions there. Давайте.
Hello, thank you for your talk. Did you try to play with 360 videos? For example, create a player on top on this technology.
Yes.
I mean WebVR.
Yes. I did play with it, not very much though, to be honest. So there is a bunch of devices that take 360 videos, and there's a bunch of these online already, and it's relatively simple because you can use them as a texture that updates every frame, and then you basically just, most of them is equirectangular, so you put a sphere around the user, and then you can do that. The problem is you can't really move yourself. So it's always a limited, I have no idea how they're going to fix that, because it's always a limited experience. You have to be in the spot that the camera is in. You can't go, okay, that's very nice, and now I move like that. That doesn't work. So it is interesting, and you can create a player on it. There's a few problems on mobile, like you have to have a user gesture to make the player start and all that kind of stuff. But it's an interesting technology to do 360 video. And I think we're going to see much more about that in the future. Because right now, streaming, it's a lot of data, so streaming is a problem, but there's companies working on standards to cut down the amount of data that you stream. So really interesting topic, 360 video. I have played with it, it works. It's just streaming is a problem.
Okay, thank you.
Hello, thank you for the speech, very inspiring. I have a quite technical question. So you say that WebVR is not about rendering, but I guess that to render VR we need two pictures to render.
Yes.
Like if we want to get this,
yes,
this 3D experience. And I guess there are like configuration for like the perspective, etc. So is it configured in VR, or do I need to care about in WebGL?
So, let me go really quickly back to the point. Where was it? VR device info. What that means is, how do I have to split? How do I have to distort things? So it gives you the parameters, and you have to take care that you render in stereo. But that's relatively easy because basically all you do is you have two cameras, how far away they are, the device will tell, like WebVR will tell you how far away the devices are, the cameras are, and how to actually distort them, and then you do the rendering. You have to render both eyes. There we go.
Спасибо за доклад, я по-русски. Меня интересует такой вопрос. Вы говорили о том, что виртуальная реальность позволяет создать макет человеческого тела, что врачи могут фиксить баги до того, как они не приступят к непосредственной операции. То есть, насколько она сейчас точна, эта технология? До такой степени?
Я не понял, извините. Is there someone who can translate that question for me real quick?
No. I'll try to interpret it. So you talked about some doctor's experience when you can render some body and prevent some crap. Okay, and before operation, doctor's operation. Okay.
Yeah.
And this man asked you, what's the precision of this rendering? Is it safe to use? Is it okay? What about now?
Очень хорошо. Давайте. So basically, yes. Da. No, I mean, like, the answer really is that it depends on the hardware you're using. But for instance, with the HTC Vive, there is someone who put on the goggles and then juggled with the controllers, right? So they are very precisely tracked. So you can make very small movements, and it's tracking really nicely. It might not be surgical, surgical precision, but it is really, really precise, and it gives a good approximation. It is a good approximation. It's not a replacement for actual training on humans, unfortunately, but it gets really close. Хорошо?